Okay, great. So we are going to talk today about how to manage soils and pasture and hay production systems for the goal of long-term and sustainable production. My name is Jake Mowrer. I'm a soil nutrient and water resource management specialist with Texas A&M AgriLife Extension, housed in the Department of Soil and Crop Sciences over in College Station. And this is something I'm very pleased to be talking about today, because I think so often when we grow things in this world, we grow them in the soil. And when we do that, we can do it in a way that makes the soil produce for us for a long, long time, or we can do it in a way that sort of breaks the soil's ability to produce for us down. And what I want to do is talk a little bit about having and maintaining a good and productive soil today. So with that, let's just sort of appreciate that soil is a natural resource in and of itself. Okay, it is like water, like air. Okay, that's the way I view it. And it is the foundation, both literally and metaphorically, that our nation is built upon. So Franklin Delano Roosevelt recognized this in 1937. With this quote that we often use with students and with folks just like you out there in the Aggie sphere: the nation that destroys its soil destroys itself. So if you think about that, it's not that hard to make the connection. If we can't produce the massive amounts of grain and fiber crops and other crops that we produce, grasses, for our animals, then we are not the nation that is a leader in the world that we are right now. So we've got to maintain and improve our soils and manage them in a way that's going to do that. So let's talk next about exactly what soil is. All right, soil is a matrix of stuff that includes broken down rocks or minerals, right, into particles 2 millimeters in size or less. And they are irregularly shaped and irregularly arranged. In between all these little tiny solid particles are air, gases from the atmosphere, and water, possibly other liquids that might not or might belong there, but usually water, and organic matter. Now, organic matter is everything that used to be alive and is now on some part of the decay spectrum. All right. And just so we're clear, in order to be soil, that organic matter has to be less than 2 millimeters in size. Okay, so all this stuff can be tightly packed or loosely packed, whatever, but it's going to be composed of these four principal components. So we know that soil is important. It's important to our productivity as a state, as a nation. We know a little bit about what soil is, how to view it. It's not just dirt, right? It's solid particles, both organic and mineral, and the gases in the water in between. But what makes a good and productive soil? Well, that can sometimes be harder to get at. But anybody who's worked the land for a while knows the difference between an area that's producing well and an area that's not, and can always make that connection in their mind to something's going on with this soil that's not going on with this soil. They can be the same soil or they can be different soils. If it's the same soil, you got a problem with that you don't have over here, right? In a well-producing place. If it's a different soil, it could be a problem in one area, or just a natural difference in native productivity and or fertility. But we need to understand what makes a good and productive soil for a pasture and hay system. And that's going to be a sufficient and balanced nutrient supply. It's going to be resilience to degradation. Okay, so what do I mean by degradation? I mean, are we mining out nutrients and leaving that soil nutrient poor? Are we compacting it and leaving it in a way where roots can't explore that volume? Okay, are we leaving bare spots and letting it erode? All right, those are examples of degradation. The next is tilth. Now, normally, if I were in a room with you, I'd ask for a raise of hands how many people have heard the word tilth, because I'm surprised that I'm just doing an informal poll, but I'm always surprised that so few people have heard the term tilth. It's an old English word that really directly means how accepting is this soil of rooting through it, right? Maybe that's a long way to go around it. And it used to be directly associated with tilling the ground in order to improve rooting. But we know now that we don't have to till to get good rooting. And you're not going to be tilling every year in a pasture or a hay system anyway. So tilth to me means, are you getting good rooting throughout the entire topsoil? Then we need sufficient depth and drainage. Now, this will often depend on the soil type, but it'll also depend on compaction and whether you have good structure in the soil that allows for good infiltration and drainage. The other things here at the bottom, large population of beneficial organisms, a small population of detrimental organisms. How do you really manage for that? Well, you can do certain things that promote a big microbial ecology. And if you have a robust ecology with a lot of small, let's say, if you can picture in your mind, small fish, big fish, right? A food chain or a food web, then that seems to be a really good way for the subsoil ecology to be operating. And when you have a lot of all the different sizes of quote unquote fish critters, bacteria, fungi, whatever they are, you tend to have a lower population of disease-causing microbial critters as well. So how do we really manage for that in a pasture and hay system? Well, it's hard. You know, we can't reduce our tillage in the pasture and hay production, but we can really manage our nutrient supply. Okay, so I'm going to start with that first. Soil fertility, the conventional approach, has to do with the amount of nutrients in the soil, and we can measure that. The balance or ratio of nutrients in the soil, and we can measure that as well. It's the ability of a soil to release nutrients, either those that are already there or those that we apply as fertilizer. All right, those are things that we don't measure, but we understand from different soil types. For example, sandy soils are less natively fertile than clay soils, but most of the fertilizer you add is then available, particularly phosphorus fertilizer is available in sandy soils, whereas in clayey soils, like in the Blacklands area, a lot of the phosphorus fertilizer you apply can be tied up in soil reactions. I'll cover more on that later. It also depends on what are you trying to grow. So if you're trying to grow a bahia, you know that you need less fertilizer to make that grow than if you're trying to grow a hybrid improved Bermuda grass. All right. So these are the things that go into it. But our definition of soil fertility is the capacity of the soil to provide everything a plant needs to complete its growing cycle. All right. That includes nutrients. That's the conventional approach. But it also includes the things that allow a plant to grow, like water, sufficient space in between the soil particles for air to diffuse, and for roots to grow and take up water and nutrients. If we don't have certain physical properties in place, we're not going to have a fertile soil either. And sometimes this gets confused or overlaps with the concept of productivity as well. So how do we evaluate soil fertility? We need to send in a soil test. We need to sample our soil and send in a soil test. So I'm going to spend just a little bit of time on this. It's not rocket science, but everybody needs to do it, because if you don't know what's already in the soil, you will have no idea how much fertilizer to add in order to get what you want. The dangers here are that you under-fertilize and don't get the productivity that you expect. The other danger is that you over-fertilize, waste your money on fertilizer for a yield goal you're not going to achieve, or an improvement in yield that you're not going to achieve. Also, we don't want to be the segment of the population that gets blamed for the dead zone in the Gulf, right? They always blame farmers for the dead zone in the Gulf and all the fish kills and the algal blooms, right? I'm just going to pause here for a second and remind everybody, because I've done the math, that a 200-acre subdivision is weirdly exactly the same size as a 200-acre farm. And you all have to get licenses from the TDA in order to spray hazardous chemicals. You all have an economic incentive not to over-apply fertilizers. A 200-acre subdivision, every homeowner in that subdivision is more likely to over-apply nutrients, that's fertilizer, and mismanage EPA-registered chemicals on their property than you are. So there's really everybody's problem, not just the farmer, okay? But if we're not soil testing, we're not doing our job as farmers. I want to make that point. Soil test is a chemical extraction that provides an index to estimate the ability of a soil to provide nutrients for plant growth. And it can identify deficiencies, sufficiencies, or excesses in a soil really well, okay? So What does that mean? The index to estimate the ability and identify the deficiencies or sufficiencies. Well, the soil test measures plant available nutrients in the soil. I want to make that clear, not total. So it provides a very close idea, one that you can work with very well, of what your plant is going to see from that soil over a growing season. That's what those numbers mean. And when you get a fertilizer recommendation from that soil test, you will use that to make up the difference in your plant requirement from what the soil can provide, all right, and what your plant needs. So the soil will provide some nitrogen, phosphorus, potassium, sulfur, zinc, manganese, any of these 16 essential elements, right? But they don't supply them all. And what's missing is what your fertilizer recommendation gives you. It's based on decades of research across the state on different soils and different crops. So we got a really, really good tool for you to use. It's called soil testing. Now, here's how it works, and this is what I mean by the index providing plant available. We've got this chemical extractant. It's like a cocktail of chemicals at the lab called Malik 3. And it's named after a guy named Adolph Malik from North Carolina State University. All right, it was his third extract. We don't need to go in the history of that today, but it is a lot like the chemical cocktail that roots exude under the ground. So if I just pause for a minute and talk about this, all of our hay, pasture grass roots are exuding chemicals in the soil. They are modifying the soil environment. They are physically pushing aside soil particles, right, and making room for their roots to grow and to explore the soil volume for water and nutrients, right? But they're also exuding acids, chelators, enzymes, salts, sugars to attract other critters to work with them, like bacteria and fungi. And so all this stuff is exuded right around every root, sort of like you see in this picture. It's idealized. They are modifying the chemical composition of the soil to make nutrients more available, okay, than the soil would normally allow those nutrients to be. And so what we do is we made up a cocktail called Malik 3 in the lab, and it has acids and chelators and salts in it. And so when you shake that soil in the laboratory, filter it, put it on an inductively coupled argon plasma atomic emission spectrometer, the number that comes out is highly relatable to what the plant is going to see. And that's about as far as we have today to go into how the sausage is made at the laboratory. But I cannot recommend enough that you take advantage of this tool and keep records year in, year out of what your nutrients are looking like so that you understand whether your soil is going in the right direction or not. Match it up with your yields. And if you're starting to go down, I'll talk about this, what you can do if you're still applying fertilizer and your yields are going down in a little bit. So the soil testing benefits, just to sort of recap, on the bottom left here, we've got a graph that shows the level of available soil nutrient. We know that by testing, right? And then we have the relative crop yield increase from fertilizing. If you're very low over here on the far left in, say, phosphorus, and you add phosphorus fertilizer, you will see a big yield increase. If you're very high in phosphorus and you add phosphorus fertilizer, you're not going to get any increase from that addition of fertilizer. We need to know where we are on the bottom of that graph to know what we can expect from the left-hand side of that graph. And then again, we can waste money on too much fertilizer. We can be part of the problem with the dead zone in the Gulf, or we can underapply and not get our economic returns that we expect back, or we can optimize according to a soil testing tool. Sample appropriately, send it into the lab, and follow the instructions on fertilizer. So again, fish kills are a real thing. It's mainly nitrogen and phosphorus that causes this problem. We know that land plants like Bermuda grass, Bahia grass, corn, they love nitrogen and phosphorus, right? But also aquatic plants and algae love nitrogen and phosphorus. And as soon as they make it into the water, we get those types of plants, algae and higher plants, growing in massive amounts, right? There's a lot of biomass being created. That biomass is made out of carbon. That carbon, once those plants die, or the algae dies off, the carbon starts getting chewed on by bacteria. Those bacteria are aerobic. In other words, they need oxygen. They steal it from the fish. And we wind up with horrible problems like this, which cause, honestly, billions of dollars a year across the US. And you can imagine, being as big as Texas, how much it costs for us to clean up recreational waters, neighborhood waters, and worse, the billions of dollars are mostly going towards cleaning up the nitrogen and phosphorus and algae detritus in our drinking water supplies. So the more we do our job, the more it's the problem of the homeowners in the 200-acre subdivision, and we get off the hook because we're following these tools, keeping our records and everything else. So how do we soil test? Let me talk about that briefly. We want to go out to the field. I recommend a tool like this. It's like a simple hand probe. They're $35, $45 on the internet. I think Granger sells them, other supply stores. You can find them at soil sampling or geologic supply websites as well. I'm going to tell you, the soil tests are only as accurate as the samples on which they're based. And one of the problems that we face is people go out and take a sample in the middle of the field. That's a point sample. A field is very variable. And so what we need to do is overcome and smooth out that variability across the field. So many of you will probably be operating on acreages that don't have the exact same soil all the way across, right? Or they don't have the exact same slope all the way across. Or you're growing hay on one piece and your pasture on the other, grazing on the other, right? Those are two different management zones. So we need to separate them out as different areas that are cropped, right? But we also need to take multiple samples over that area. And so one of the things we say is that we need to overcome natural field scale variability by taking multiple samples. The best way you can do this is just walking out there zigzag or willy-nilly and take 10 to 15 samples out there, just walking a zigzag line from the gate to the far side and walk back. I'll tell you that recently I did 17 acres in about 15 minutes. Okay, I had my tool like I just showed you, and I had a 2-gallon bucket in my other hand and a putty knife in my back pocket and some great value vegetable cooking oil release spray, because if you're taking a blackland soil sample, you'll take it in 10 seconds and you'll spend 10 minutes trying to clean it out of that probe. So vegetable cooking oil release spray will not interfere with the laboratory test. And if you spray it on your probe, you will have good results and just popping that little core out right there, okay? We want to take it to 6 inches because that's what all of our work has been done. And then we'll pop it in a bucket, take your putty knife, whatever, and that's what I like to use, or 5-in-1 I carry in my back pocket. And then when I'm done taking my 15 6-inch cores, I throw it down in the bucket and I chop it all up. Now, everything in that bucket is smoothed out. So I fill up the bag to the fill line, which is a dotted line on the bag. It says fill to here. All right. Then you can toss everything else out of the bucket because we've already smoothed it out and move on to your next acreage. A management area should not, for your production systems, exceed 45 acres. All right. So we want you to take 12 to 15 samples for that large an area. Now you can get better management by breaking that up into smaller samples, okay? For instance, 20 acres or 10 acres a sample. I don't get a dime out of this, and I'm not trying to push you to spend more money than you do, but I really think tightening up your nutrient applications is going to help you make more money and manage your soil better so that it's productive for a longer period of time. How do you decide what a management area is? I kind of touched on this a little bit earlier. Look at your soil type. Do you have a sandy soil on one part of your acreage and a blackland soil on another part? Do you have a light brown sort of loamy soil and a sandy soil or a blackland soil? Look at these things and separate them for your soil test. Don't composite them together and try and smooth that out. Topography, again, if you've got a slopey area, you may want to separate that out, even if it's not fenced differently, even if it's treated the same, you may want to soil sample it differently and manage those nutrients differently. And then also, how are you managing it differently? Do you have one as rotational grazing and the other as hay cutting? Do you have one just as a large open grazing area and another as a cornfield, silage, that sort of thing? Okay, that's different management systems. You're growing different things for different purposes. You have different expectations. Then treat them as different management areas as well, and composite soil samples for those areas as separate samples. So that's it on soil sampling and testing, other than just, use the brain God gave you, and don't sample under the hay ring, because you're not going to need any fertilizer. Don't go to the worst area and expect it to represent your field either. And don't just go 10 feet inside the gate, take all your samples and leave. So those are my tips. How often to soil test? I recommend annually for intensively managed fields. We have large inputs of fertilizer or soil, and then significant hay removal. And then every 2 to 3 years if it's less intensively managed. If you are applying fertilizers, you really need to do this every year. Okay, if you're applying fertilizers every 2 to 3 years, do it on that same schedule. If it's rangeland and you're not ever applying fertilizers, and you can't afford to because you got 1 cow per 15 acres, I don't see any reason to soil test. Okay, do it for your own records. When to soil test? If you have an acid soil, and some of you might, soil test in late fall so you can get that limestone out there and have it sit for 2 to 3 months to go ahead and do its job. All right, maybe even 4 months, so that it can react with the soil and bring the pH up before green up. So you want to do that in September, October at the latest, and then use that result to get your limestone out on your fields, so that by the end of February to mid-March, you are ready to fertilize, okay? And you got your pH adjusted. For alkaline soils, you're not going to add any limestone to those, of course. So make sure you're 3 to 4 weeks at least before green up, so that you can get a soil test back in time to make your management decisions and purchase and apply your fertilizer before the plants really, really need it, okay? So how do we get efficiency out of a fertilizer? We've done our soil testing, sampling testing, we got our results back, we purchased our fertilizer. When are we going to put it out? How are we going to put it out? What kind are we going to buy? The soil test will tell us how much to put out. But the use efficiency, getting the most out of it, in other words, depends on 4 things. Depends on timing, when do we put it out? All right. Placement, where we put it. Do we put it on top? All right. Do we put it underneath the soil? How deep do we put it? What kind of fertilizer do we buy? Do we buy a granular MAP to cover our nitrogen and phosphorus? Do we get a 1137O, which is a liquid, and band it under the ground? What kind do we get? Rate of fertilizer application. You're going to know how much of each nutrient to add based on the soil test recommendation. And you're going to know what NPK mix to get based on that recommendation as well. So I want you to think about what the roots are doing here when you apply your fertilizer. So nitrogen, it's really easy to put on top. It will wash into the soil, no problem. Okay, it will dissolve and go in almost every form of nitrogen, no problem, except for nitrogen in poultry litter. You need to let that, great form of nitrogen, by the way, but you need to let that break down a little bit before it's going to be available. So that needs to go out a little bit before green up. Potassium dissolves poorly in clay soils and really well in sandy soils. It moves around a good bit. And phosphorus dissolves poorly in all soils and stays wherever you put it. So if you're slinging out MAP or DAP on top, it's a great way, it's easy to put out, but it's always going to be on top, okay? So any chance you get to rough up your soil, you may want to apply phosphorus fertilizer as a granule before that and go up and rough up the soil, or if you're reestablishing, go ahead and till it in pretty well. If you have the type of equipment where you have a low profile knife that can do liquid injection behind a coulter, that'll open up a furrow and let you put the phosphorus as a liquid down 2 to 4 inches, you'll be a lot better off. The reason I say this is that when it's dry and droughty for a long period of time and all your phosphorus is in the top inch of the soil, the driest part of the soil is the top. Fertilizer nutrients have to be dissolved in the soil water in order for a root to take them up. They will not take up a dry nutrient. So if all your phosphorus is at the top and all the water is at 4 inches, now the root's got no access to the phosphorus. So if you put it 2 or 4 inches down, either by incorporating it in when you have the chance to disc up the field, or knifing it in with the right equipment when you have the chance. Then you can leave your plant roots in a much better situation for picking up phosphorus during droughty times. And that's when they're going to need it too, okay? Now, nitrogen is always going to be accessible to the lower volumes. The rain is going to dissolve it. It's going to wash down naturally and easily. Potassium depends on the soil, but phosphorus, you need to place it where it needs to be somehow, all right? So nitrogen management, there are some problems with that. It's not magic. It's not always easy. I'm sure you're aware that putting nitrogen fertilizer out can lead to losses of your investment. So just a quick reminder of the best way to avoid nitrogen losses from environmental conditions. We need to put out nitrogen, especially if it's surface applied, shortly before rainfall, okay? Or put it under the surface of the soil, 2 to 4 inches. And we need to apply it as close to when the grass needs it as possible. Okay, so we can split our applications for most crops. At Green Up, you can put out 30% of what it needs for the year. If you're doing hay, you can put out everything it needs, knowing that it's after you cut your first cutting, you're going to come out and reapply for the next cutting, right? So if you put it on the surface and you don't get any rainfall for 48 hours to a week, you're probably looking at a 20% loss. But just putting a little bit under the surface, you can see, starts to really conserve your investment. So knifing it in is a very good way to save nitrogen. However, if you can get 1/4 of an inch of rain within 24, 48 hours of putting it out on top, I'm telling you, you've done a really good job of timing that application. Okay, spring, we get a lot of rainfall. If you can find a window, don't drive over your pasture when it's wet. Okay, let it dry out. But if you know it's going to rain in the next day or two, and you can get out either some urea prills, some UAN liquid, or some MAP or DAP out there, then or ammonium nitrate, if you can still afford that. Those are all great sources, especially if they're getting rained in within 24 to 48 hours of putting it out. Potassium really depends on the need. If you get a recommendation for more than 75 pounds per acre, which is more common in East Texas than around the Blacklands or the Coastal Bend or even the Abilene and Big Country area. But it's not unheard of. If you're getting 75 pounds per acre recommendation for your potash fertilizer, then you need to split that up. Otherwise, your first cutting is going to get greedy and take it all out of there, okay? So if you need 75 a year, you'll get a note at the bottom of your A&M soil test recommendation to split that up so you won't forget it. And you want to put potassium out shortly before the need. That's that rapid growth stage, right? So your warm season grass, you're going to be looking at April or something for maybe a different part of the world, probably March for us. And if you're looking at a cool season grass, of course, you're probably going to get some green up starting right around the middle of February, as it says. You want to get that out there beforehand. And so I do recommend varying your systems and incorporating more than one type of forage. Okay, and I'm going to go over that in a little bit as well. Phosphorus, you really need to adjust the pH if it's acid in order to handle this well and get the most efficiency out of it. Also, timing is really, really important. If you can place it under the soil surface, 2 to 4 inches, you're going to be doing yourself a world of benefit over slinging it out on top. All right. So, and then, liquid and granular sources are both effective. I think liquid is a little bit better, particularly if you can put it on, say, 30 to 20 inch centers, knifing it in and putting it 4 inches down. I think you're going to have the best response per unit of P2O5 of any method of putting it down. So my best recommendation, I know it's not possible for everybody, is to apply a liquid subsurface, like an 1137-0 or a 1034-0 as a called ammonium polyphosphate is what that be. And also apply this close to when the grass needs it. But we don't want you to split apply this. You don't need to, whether it's granular or liquid. The problem with granulars is that you may never access the chewy toffee center of the prill because diffusion is limited. It's very insoluble, phosphorus is, and it doesn't travel very far, right? It's not very mobile. So a prill tends to have a diffusion zone. Once that's filled up, it won't dissolve that solid anymore until plant roots come out and take the phosphorus away from this diffusion zone. So clays can be a little under an inch of a diffusion zone. Loamy soils can be about 1.5 inches. Sandy soils can be a little bit bigger. Okay. So that's what we're looking at right there. And roots have to go to the prill to get it. With liquids, we've got a more dissolvable source, more soluble source of fertilizer that lasts a much longer time and tends not to get so tied up in soil reactions. So it's a little bit more efficient. It is a little bit more expensive. So it's almost twice as much as efficient using liquids over granular. Okay, and as you start to approach twice the price, then you have to start making an economic decision about whether it's really worth it for you to do that. Plus, there's specialized equipment involved. I'm definitely not saying put liquid on top because I just don't think there's any value in spending extra money for liquid phosphorus fertilizer and then putting it on top because it's not, you're not taking advantage of the best properties of liquid. All right, so we talked about all the fertilizer stuff, management, and what makes a good and productive soil. In row crops, we can reduce tillage, okay? You know, in hay crops, we can't really do that. We're not mechanically disturbing the soil very much. And so we're probably already instilling in our soil a large population of beneficial organisms because we have living roots in the soil all year round. And there's not much we can do about deep tilth either. We probably got pretty good organic matter buildup compared to a cotton system, right? So the other thing we can do, if you've heard of soil health or regenerative agriculture, permaculture, soil quality, sustainable conservation management, all of these things tell us to do the same things with soil, which is to reduce disturbance, reduce tillage, build up organic matter. I'm telling you, if you can make sure your roots are growing, you're going to have it all, okay? And the things that you can do in a grass system, all right? So these are the things that you are recommended to do to get soil health, to get soil quality, to be aligned with regenerative agriculture or permaculture. Disturb the soil as little as possible. Diversify soil organisms through plant diversity. Maintain living root systems year-round. Maintain soil cover through residue or living plants. Promote soil organic matter and minimize and address compaction when necessary. Well, in a perennial grass system, you got all of these except for two, right? And maybe you already have plant diversity. So I'm going to focus on these two things for the rest of the presentation because you already got organic matter. You already got soil cover with the perennial grass. You got a living root system year-round, and you're not tilling the soil, right? So what's left? Well, a cropping system that's more diverse than just one plant and making sure you let those roots grow, all right, by addressing compaction and not cutting or grazing too low, okay? So this is just a real quick idea visually of what's happening with the roots when you cut your plants too low or allow the cattle to stay on too long and graze too low. You know, photosynthesis is what allows plant parts to grow, both above and below ground. If you have a short plant, you have not very much photosynthesis, and those roots have to retract because you can't support them, and they're not needed to grow to supply the plant that's there. So it's balancing out its economic concerns over, do I waste all my photosynthesis on supporting roots, or do I spend all my photosynthesis on building more above ground matter? And it's going to be vegetative matter on top that wins, okay? So now when you lose roots down below, particularly in a blackland soil, the opportunity to grow them back comes at great expense because of that clay can shrink and swell, right? And so it costs more to reinvest in those and reestablishing those roots afterwards. So don't overgraze, rotationally graze, don't graze down to, and don't cut down too low, okay? I know there's this intensive grazing idea out there. You got to be really careful with that and not graze too low. Otherwise, you're going to be looking at roots like this and it don't work in blackland soils. Excuse my Georgia-ism there. All right, so here's what's going to look like under the ground with high compaction and low compaction. The roots that are hanging in the high compaction area circle are clearly coming from above. The roots in the low compaction area are coming out of the soil. Okay, so dig a hole every once in a while. Look at what's going down under the soil, and see if you got roots down there. And if you don't, it's a good chance that you have compaction, which is going to prevent two things: root proliferation and water infiltration. And both things are associated with a good and productive soil, right? How can you, what indicators can you have? Well, it's caused by heavy equipment and livestock traffic. It can be caused naturally too. Soils can just become compacted. You know, blackland clays where they're shrinking and swelling are going to be compacted during certain parts of the year anyway. Poor infiltration of rainwater, you know, I'm sorry, but that's also just a natural characteristic of blackland clays. But if you dig up a shovelful and you drop it on the ground and it's got a little bit of moisture and that shovelful doesn't break up, that's blocky soil structure. That's not a good thing. Shallow root growth, dig a hole and look. Are you seeing swollen tips? Are you seeing sudden horizontal root growth? And what seems to be a compacted layer that's harder for you to get a knife or a nail through than the layer above or below it? And also, is there water stress in your grass where the soil is moist at 10 inches or below? These are things you want to look for, right? If you're seeing this, if you drop this from chest height and it don't break up and it's moist, that's bad, okay? This is bad too. I want to urge you to wait until your soil dries out to drive on it every chance you get, because I know if you've ever taken a big piece of equipment out there when it's wet, that you know where you drove forever, because that's where the grass is the shortest. So be mindful of that. Avoid as much heavy traffic on wet soils as you can. It can be addressed through renovation. Now, what do I mean by renovation? I have to be careful about this word because it means a lot of things to a lot of different people. I learned this when I moved out here. What I mean is get yourself a ripper on a forward swept shank. It's going to be hard. You may only have the equipment to pull 4 or 5 shanks through a field in the blackland. Okay, as 85 horses is probably only going to pull 3 shanks to the depth you need it. You know, getting closer to 200 horses is going to do 4 or 5 shanks much easier. So this picture on the right is a government job where there's one guy working and a bunch of guys watching. But basically, the equipment you want looks like this. You're going to have to do this in a pasture that's prone to compaction every 3 to 5 years, and a pasture that's not, probably every 5 to 7 years to maintain productivity. And what I told you earlier is you keep your records and you fertilize the same, or you fertilize according to our recommendations, and you're seeing a decline, it's probably because your roots aren't happy and they're unable to access as much soil volume. So what this thing does is it basically breaks up the soil and causes a fracture to meet in between the tools, the ripper attached to the tools, the shanks, and you need to set it at the right depth, which should be about 1 to 2 inches below the compacted layer, and about the right distance would be 20 to 30 inches there, I think is what they say. So 30 to 42 inches. I think in a lot of clays, get closer to 30 is going to be better off for you. And what this does is just creates a fracture through that compacted layer to meet in between the shanks and the tools. And this will make a world of difference to you if you do it on a regular basis. As you start to see that decline in productivity, you know, each year is going to be different according to rainfall, particularly if you're dry land. But if you see a trend over a few years, you need to address this mechanically with a ripper. And it doesn't disturb or turn over the soil, it just fractures it, okay? How do you know how deep you are? Well, a real cheap way to do it is to take an 1/8 inch rebar or something like that, or even a wire flag, or press it down in the soil. And the depth at which that thing starts to bounce, or that wire flag doesn't want to go in as easily anymore, that's the depth you need to set 1 to 2 inches below. So that's how you address compaction in a perennial grass system without turning over the soil, right? And if you ever have a chance to reestablish, I recommend that you do turn over the soil and you do find that compacted layer and till the snot out of it, so that the next few years are going to be much easier on you and much more productive. Then you go back to your perennial grass system. All right. Plant as soon as you can after that. Don't leave it be. You don't want weeds to start out competing, and you don't want erosion to happen. All right. Those are our enemies in soil management. Now, the last thing I want to talk about here is crop diversity. So don't have a monoculture. You don't have to have a St. Augustine lawn out there. My brother is real proud of his system back in North Georgia, and we sat on his porch a few months ago, and he was bragging about his system. So he's got a mix of tall fescue and what's probably common Bermuda right now, but he'll reseed with an improved, and sweet clover. And in the winter, he's got Italian ryegrass growing. Ryegrass growing. So he's got 4 species growing over there, and something that does well during the cool season. Okay. So what he's got is a really sustainable system with a lot of high quality hay coming out of it longer in the year than anybody else who has just Bermuda or just tall fescue going out there. So what can you do? Well, if you're going to plant cool season forages, this is one of the best ways to get your feet wet in this area. Plan ahead. Identify your seed supply in August or September so that you know you got it available. Decide what you're looking to get out of your cool season forage. Do you want to put in nitrogen into the ground and save yourself some money on fertilizer in the spring? Do you want to have better root proliferation and save yourself, frequency of ripping, right? So some roots are actually quite strong and can help you manage compaction a little to some degree. And when will you need that forage to be available? Rule number 2 is match your species with your soil and climate. So Vanessa is going to talk, Dr. Corey Olson is going to talk a little bit later about selection. And you may ask her some questions about that if you're on. And if not, hopefully she'll cover this. And if you ever see her out in the Aggie sphere talking, ask her which species are right for your soil. But come prepared, do your homework, know what kind of soil you got. All right, so some species don't tolerate cold. Some got to be vernalized, right? And some don't like, some need a well-drained soil, some need acidic soils, some like alkaline soils. If you have a no-till drill, then you're going to be best off in terms of the amount of seed you need to get good establishment. You can sling a lot of stuff out. You're going to be looking at bird problems possibly, and you're going to be looking at somewhere from 150% to double the seed you need to get the same biomass out, okay? If you're using it for grazing, you're going to need a lot of seed so that you can get a lot of high quality forage out of it. So wheat, oat, and rye or ryegrass, you can just overseed, you can drill it in, or you can sling it out. You will get it to come up. It's a high quality forage. It'll reduce your hay costs over the winter, right? And produce hay earlier. And it utilizes land and rainfall and nutrients and more efficiently. So, even though you got living roots from your warm season grasses, they're mostly dormant. And so you get a lot better soil microbial ecology out of this when you have actively living roots in a part of the year that you wouldn't from your other warm seasons. If you sling it out, it can be hard to have good seed soil contact. So drilling is better for you. I suggest that you're trying this out, you do it on a small part of your acreage first and see how it works. 5, 10 acres or something like that. No more than 5% of your total land, okay? And then see how it works. If it doesn't work right, don't give up. Try it again, but don't spend a lot of money on your whole acreage experimenting, being a scientist on your own land all at once. Try it out, see what works, and then tweak it the next year until you get it right. All right, so small grains are going to need fertilizer. So you will have more fertilizer investment, but you will get that back in feed, right? So you're going to need about 40 pounds of N for every 1,000 pounds of forage, 10 pounds of P2O5 at the top end for every 1,000 pounds, and 35 pounds of K2O. So that's what you're going to be looking at if you want it for forage. Plant 6 to 8 weeks before the first killing frost, get it germinated and everything, and it'll live through if you choose the right cold tolerant species. 120 to 150 pounds of these types of grains is usually what you need. I know that seems a lot, but you're growing it for forage, okay? And 80 pounds to 120 pounds of barley and oats. And so this is a lot of seed, but it will come back in the biomass for you. So if you want to graze it, get out there, you wait 2 months after it's planted, make sure you have 6 inches of top growth, you'll get some value out of that. And terminate in May at the latest to reduce competition with Bermuda grass. So a lot We often, back in Georgia, would spray our ryegrass with glyphosate around February and March, right? And then that would be before green up so that it wouldn't kill off the Bermuda grass. We often make just, an alternative to that, which I think is more common, is to actually cut that first cutting early. And it's mostly ryegrass, right? Still a very good hay. I know Dr. Corey also is going to talk about that. And give it to your own cows. And then you're doing really good right there, right? Or graze it off and then start selling your regular warm season as hay. Legumes are great. They're even higher quality in terms of protein, and they're going to leave behind nitrogen and reduce your nitrogen fertilization costs, right? They do a little bit more management intensive. So you need to pay attention and make sure you're picking the right thing, and that you don't have problems with it coming back later. So Vanessa Corrier Olson is going to talk about that hopefully later too. And we do have publications on selection as well. So perennials can act like annuals. You need to be really careful. So you need to recover hard seed to make sure it's not coming back. And really, really make sure you figure out what you need for your soil, and then don't put out nitrogen, right? So let that stuff produce its own nitrogen. So it can give like 100 pounds per acre nitrogen back to warm season grasses, which could cover you for, the first couple of cuttings sometimes, or at least the first one. Livestock, better digestibility a lot of times out of these, and it extends the grazing season. So I start to see these things coming up in January, late January. And I think by now in most years, which is late February, we'd be able to get on these with the grazing. So winter feeding can be reduced by 4 to 6 weeks, usually every year, by planting a legume that has an early growth. So I recommend winter pea for most soils because it really comes on early. And then I do not recommend burst seam clover anywhere in Texas. It just comes on too late for you. But red clover can come on late and put on some good biomass. And I don't recommend vetches because of they tend to come back. They're a small hard seed. They tend to come back when you don't want. So these are all things you need to look at. Look at the Southern Cover Crop Council website for more specific information on cover crop fact sheets for blacklands. Overall benefits for cool season forages, just to recap, we get improved pasture and livestock productivity. We're going to have better economics almost every time we do it. Legumes reduce nitrogen fertilizer costs, active roots year-round keep nutrients from being lost, and they're providing to a good and productive soil, right? Competition reduces weed pressure and herbicide inputs. And that's what makes, folks, a good and productive soil. Sufficient nutrient supply, resilience to degradation, tilth, sufficient depth and drainage, large population of beneficial organisms, and small population of detrimental organisms. And those are some of the key highlights to the tools you can use to get a good and productive soil. So there's my picture. There's my phone number. Andrew or Brent, y'all want to ask some questions for the recording? I'm cool with that.